Thank you very much, Dr. Newbill, for this introduction. I'm very happy to be here today to talk about this project. We have been working on this for a little bit more than a year, so thank you very much, Dr. Tanya Bobo, and who is also here today, and also my colleague Pamela Tister from Center for Gerontology. And we also have a lot of great students working on this project. Akash spent a lot of time on the app, who is also here today. And Emily recently joined this project and will be working on the following up testing, right, of the app in the next phase. So let's start with the concept of biophilic design. So that is a design approach from architecture and interior design. So the goal of biophilic design is to create good habitat for people as a biological organism in the built environment. This is deeply rooted in the nature of human, right? So we evolved in the natural environment, and we have this biological affinity to nature. There are many ways to integrate the built environment with nature. So for example, nature in the space, which means that the direct presence of nature in a space. So for example, this traditional Japanese tea house, right? They give you a direct view of the nature within the indoor space. You can see the trees, the grass and waters outside. And then there is another approach about biophilic design, the natural analog, which means an indirect representation of nature. For example, we can borrow any patterns, textures, and contours and materials we can find in nature to recreate or in indoor spaces. For example, this one is a bamboo ceiling. And there are many other examples of biophilic design adopted in many different types of built environments, like houses, buildings, infrastructure systems, parks, so on and so forth. This increasing adoption is because the benefit of biophilic design on human well-being has been proved. And there is a very important growing population that might benefit from biophilic design is the seniors, the older adults. In 2020, we have 54.1 million people. That's 16% of the entire US population that's older than 65 years old. So that's defined as older adults, right? And then these numbers will project to be 94.7 millions in 2000 by 2060, and that's 25 of the population by that time. And this growth of population will create a housing and care need, right? Some of them will prefer to remain in their own homes or independent living, while some others might need to go to assisted living or nursing homes where the support for activities of daily living can be provided. But whichever type of indoor environment they choose, this environment have to be able to promote the physical, cognitive, and social well-being. And biophilic design can bring these benefits by reducing stress and support cognitive functions, even for those that might be cognitively vulnerable. It can also promote sensory comfort and improve mood and emotional well-being. But there are many challenges to implement the biophilic design in senior living. So the first limitation is cost, because a lot of these biophilic features like fountains or indoor greeneries are costly to create and maintain. And there's also a risk of non-compliance with building codes or any other design standards, because although they have been widely adopted, they are not really incorporated or governed in the current design standards. And lastly, there's always potential accessibility or mobility barriers considering the context of senior living. And our solution is why not use augmented reality to bring digital nature into senior living spaces. So at the very beginning of the project, when we proposed this project, we were thinking about different approaches of AR, for example, projectors or head-mounted devices and mobile devices. But quickly we decided to focus on the mobile AR because this provide the most accessibility. It's very flexible, affordable to be used by older adults, and compared to something like head-mounted devices. And we also explored both smartphones and tablets. And again, because of the reason of flexibility and usability, we finally fully focus on tablets because it's kind of difficult to for seniors or for older adults to play like small smartphone, use fingers to move or resize the 3D objects. And here are some snapshots of the app we created, but later Akash will give a demonstration of the app. Because we want to really balance the diversity and scale of the biophilic design models versus the quality of the model. So we choose to use generative AI for the 3D models. We want to have a good collection of different models, different types of biophilic design features, attributes, and it's really time consuming, and it's impossible to have this good collection within a short period of time just by just relying on human designers. So we took a 4-step approach to leverage generative AI to create this 3D biophilic models. So first, we create a AI agent that understands biophilic design and senior living. We provide AI with biophilic design principles, including the categories, attributes, and then in the ideation stage, the AI prompt to generate diverse design ideas, including materials, forms, textures, functions, etc., to describe the biophilic design. And then these descriptions of the design ideas are then fed to the AI to create 2D image sketches of the design ideas. And then this 2D designs finally fed into another generative AI model to transform them into 3D biophilic models. So for the first 3 steps, we use GPT because it can generate both text and images. And then for the last step, we use Mesh AI to make sure that the AIs understand the design tasks. We did a lot with the prompts. So for example, we use chain of thought, which simply means that we guide the AI step by step instead of end to end, right? So we can check the intermediate products or generated products from AI. And we also use few short examples to guide GPT. Later in next slide, I can show some simple examples of the in the prompt we provided to AI to let it understand what are the expected biophilic designs. And we also use self-checks in the prompts to make sure that the AI can double-check its design idea if they are reflecting the biophilic design principles, and if the 2D biophilic designs reflecting the design ideas correctly, so on and so forth. So here is one example. We first provide the, I didn't show all the prompts, right? So before this, we already, taught the AI about biophilic design and senior living, but here we're just providing the AI with some examples of biophilic design created by human designers. So it's a Lotus Bloom table, and we describe the functions, materials, why they are biophilic to the AI. And then we ask it to generate, to create some ideas for new Biophilic designs. So the first idea provided by AI is Savannah read screen, and again, we ask the AI to define all the different aspects and answer why is Biophilic, and then summarize this into a image generation prompt. So on the other side, right, and then this prompt is provided to the AI again to create a 2D example, and then um, to create more 3D examples in following steps. So here is just a collection of the models we created. In parallel to AI, we did also use human modelers, right? So some of these models, I'm not sure if you can tell, are created by humans, and some are created by AI. And Another important step in our solution is to test these AR Biophilic models to make sure that they're tailored and they fit well to the real-world senior living facilities. We tested, and we are planning to do more tests in our partner, Warm Hearth Village. So they are a good candidate because they have both assisted living and independent living. And there's different types of facilities. They have different characteristics of indoor environment. Assisted living, they have a mixture of small individual private spaces and large shared spaces, like restaurants and long corridors. But independent living is similar to the typical residential houses and apartment buildings. So here are some photos of we took during our site visit and during the tests. So these are the, I don't know, your right side, right? These are the assisted living spaces. So you can see they even have a art gallery corner. And this side are the floor plans of the independent living. There are many challenges, of course. For example, how to make sure that we have a very realistic AR environment, how to anchor the Biophilic models on not just floors and table surfaces, but also walls and ceilings, and how to automatically scale the models to fit the indoor space proportions. How to improve the texture and visual realism, how to personalize the models using the memory references so we can create a more personalized model to our users, and how to improve the usability, to use voice control. I'm not sure if you can notice this in this demo, very short demo. This is using an older version of our app, which has a voice control function, but then it's very tricky because it sometimes doesn't recognize lower voices or broken sentences, and so we are still trying to improve it. Finally, we want to do more testing and evaluation of the AR models, Biophilic models effects on seniors. So we want to start with the cognitive impacts. We are already scheduling some tests with our participants at Warm Hearth to conduct some pre and post-use tests to evaluate the impact of the app. So lastly, Akash will give us a quick demo of the app. So let me.
Okay, so I'm gonna run you through a quick demo of the app. So we built this app using Unity with the help of the AR Foundation, which is a framework used to develop AR applications. So it uses plane detection software, which basically, it is visualized through the dotted areas, if you can see. Oh, you can't see.
So we were trying to cast the tablet desktop to our laptop desktop. So sometimes it's um,
Okay, I think it's working now. Okay. So Unity's AR Foundation uses a plane detection software. It can detect both vertical and horizontal surfaces, but it works a lot better with just horizontal ones. So if you can see the dotted area, that's the space that it's able to detect and track. So if you can see the scroll bar down, here is the menu of our created 3D objects. So if you can just click on it for the object to spawn here, and then you can use your finger to drag it around. You can increase the scale, and you can also rotate it according to your requirements. And just example of like another object here, and you can just drag it to the trash can here to just get rid of the objects. And so just to get you familiarized with the range of objects that we have created here, like, as you can see, some are like just direct representations of greenery from nature, but some other things are more of like a indirect parallel or like a nature analog, as Professor Zhang was talking about. So for example, this chair is based off a bird's nest. So as you can, the material itself is like, it looks like it's woven rattan sort of material, and then it's dangling, right? So, maybe we can also bring in a tree and then make it dangle from there. So that's like an example of like a weaver bird's nest, I guess. And then for another example, let's do this one. So the stone here represents like natural volcanic formations like basalt or something like that. And then, oh, there we go. And yeah, you can see the stone, it's like volcanic kind of represents volcanic formations with basalt. And then it's being like sort of reclaimed by nature. Here, that's like reclaimed by moss, etc. So let me just add in a few more objects to do like a themed design. The theme I want to go for is meditation. So I want to do like a nature meditation sort of thing. So we have this one. So this is like more of an example of nature in space, right? Because there's a tree and then there's ground seating. You can like sort of sit there and like meditate, reflect. And let's say I want to create more of those spaces. I bring in like maybe this alcove sort of thing, nature alcove. And then maybe let's say I want to create like sort of a partition between both of them. Let's say multiple people are using them and you want to give them some sort of privacy. So this object here would be an example of a nature analog, because it's not just like a direct representation of nature, but rather like, it's a partition screen. The frame is like wood, and then the screen itself are like, ferns sprawled across. And then, let's put a couple more of them. Ooh. Okay. Yep. So I guess this design itself, I guess, would be more suitable for like a bigger space or an atrium like this one. But if you want like if you're doing it for like a smaller space, we could maybe just go for like a coffee table like this one, and then put in more chairs. So yeah, this was like a very quick demo, and yeah, thank you so much. In the future, we would hope to add in more animations and more sounds to create like a more immersive space, especially for spaces where a real biophilic makeover is not possible. Thank you.
This space has never looked so good. What questions do we have? In the room or online? I'll hold the mic.
Thank you. Hi, thank you so much. Fantastic talk. Really enjoyed hearing about your project. How are you planning on pre-post testing with older people? What's that going to look like with this project? Thank you.
Yeah, that's a very good question. So we did some pilot tests just to gather some feedback with our, people we find from our social networks. Anyway, so later we want to do some, for example, simple tests like Stroop test, which can be easily gamified and deployed on maybe tablets. So before they play with this app, we'll let them do the Stroop test first, and then after that we'll do it again and see if there's any difference in the because it helps measure the cognitive reaction sort of time. So that's one of the plans, but maybe we'll also include the measure of physiological other signals, but yeah, that is the current plan.
Okay.
But we'll try to. There's always a challenge to recruit more, participants. Sometimes they're not interested in technology. Sometimes they are worried about if their data is leaked or whatever. Yeah. And we do have 2 tablets today here. So if you want to play with it, we can do it after.
That's the best news. You can play with it. Can you talk about how, what disciplines are represented on your team, both who's here and also on the rest of the team, and how you all got started working together?
Yeah, so we we have a lot of students who are not here today. So Akash is electronic and computer engineering, and then Emily is biomedical engineering, and we had Faraz. He's already in Georgia Tech. We failed to keep him. So he's from architecture. I'm from construction, kind of building construction background, 10 years same. And Pam is from Center of Gerontology, so she's the expert of older adults. We have other students from computer science, so that's the team.
How did it come together? How did y'all find each other? We have silos here. How did you get out of them?
Well, it's not easy. So I was trying to bring people together, especially students, to understand the big picture instead of just to put them on a specific role and, okay, you're just a software developer, right? So I'm trying to bring them together and let them discuss to figure out what is the best solution instead of me like saying, okay, let's create 50 whatever chairs. And we also did a lot, not a lot, but a few times of like discussion with our end users, right? The older adults, seniors. And later we will ask maybe both of you to also talk to them. They haven't really met our participant yet, but hopefully this will help to improve the quality of the production, right? The solution. Yeah.
I love it. Thank you so much. We're at time, so I want to thank you all for sharing your work with us this morning. And I want to thank you all for being here. We'll be back again next week. There's some more donuts and coffee over there. Make sure you enjoy those. We'll have more again next week with another mind-blowing presentation. So be here one more time. Have a great weekend. We'll see you then.
Thank you very much.